Hi everybody. Alright, what we're going to do in this video is a single factor analysis of variance, or sometimes called an ANOVA. And what we're going to do in this particular demonstration is we're going to use a classic example that I got from one of my old textbooks. And this has to do with a jury trial. And the research question is, would defendant's record influence jury members? So what they did, they took a group of people. So you got 1, 2, 3, 4, 5, 6 people in the clean group, which means defendant does not have prior criminal record. And then they took 5 people from the criminal group, which means defendant has prior criminal record. And then they have a control group where the defendant has no prior criminal record. Let's change that to a singular. And so what they apparently did in this, they asked the jurors to fill out a questionnaire, and apparently the questionnaire probably just asked them, do you think the criminal or the defendant would be guilty or not guilty? And 1 is sure that the defendant is guilty, to 7 sure the defendant is not guilty, and you have your other numbers in between. Therefore, your hypothesis, or what you're saying in the hypothesis, is that at the beginning of the study, all of the groups, the 3 groups, are equal in their response. And your alternative hypothesis is that they are not going to be equal at the end of the survey. We're going to use the alpha level of 0.05. Now, what I always like to do is I like to get the means before I actually do the ANOVA calculation, and you can use the simple average procedure to do that. Just to also let you know, in the auto sum, they do have an average command there, but you got to be careful in the numbers that they select. And I did the same again for the criminal and same for the control, because what I want to do is, after I do the ANOVA operation, I want to compare my means to the means of the ANOVA function, just to make sure that we agree. I also did a sample standard deviation command. You can go to your more functions, statistics, scroll down until you get to standard deviation for sample, because this is a sample, and I did it for each of the groups. And I also did a sample of for the variance, because it will report the variance also after you do the calculations. All right, now this is pretty easy procedure. In Excel, you go to data analysis. First command, first function is analysis single factor, and that's what we want, because we are comparing the means difference between 3 or more groups, in this case 3 groups. If you remember from last sessions, we did a t-test, and t-tests are used for 2 groups, while in ANOVA's analysis of variance, do it for 3 groups. However, just to let you know, you can also do analysis of variance for just 2 groups. Okay, so once you select your function, press OK, and it asks for the input. Now, I did this already, so you input all of the data. Be careful, don't include your mean, standard deviation, and variance. And make sure labels, if it's not checked, check it, because I did include labels. And also alpha level, I'm keeping it at the default 0.05, and I already told where Excel where I want the output, so I'm going to cancel it since I already did it. Alright, let's look at what we got here. First, you check the means just to make sure you do agree, and we do agree on the means, and the variance we agree upon too. Just to let you know, the reason I did the standard deviation, because if you're going to write a report on this particular study, you would report the standard deviation as opposed to the variance. and then this is your descriptive data information. Now this part is your inferential, and what you want to do, we're lucky, and the ANOVA will automatically calculate the critical boundary for you, so that way you don't have to go to the tables for the F table distribution. So since we look at the number, look at the p-value, and I wrote it down here. Since the p-value 0.00057 is less than the alpha level of 0.05, and the F statistic of 13.9876 is greater than the F critical of 3.80. Let's change that to 80557. You know to reject the null hypothesis. If you drew a bell-shaped curve, your null hypothesis, these values, the F stat and the p-value, would fall into the reject the null hypothesis. So there is a statistically significant difference among the means of the three groups. They are not equal. Then your next step would be to compare the averages of the groups. And as you can see here, remember, number 1 is sure the defendant is guilty, and number 7 is sure the defendant is not guilty. And if you look at it, definitely you can tell that the people with a criminal record, the jurors that would influence the jurors to believe that the defendant is guilty. And then you've got your other number clean, you're in between, guilty and not guilty, and 4 is close to that. Now, Excel does not have what is called a multiple tests procedure, or a post hoc procedure, where you can do these procedures where it will divide the mean difference between each of the group. If you want to, you can do a series of t-tests to do the same. But I think what we can see here is that the criminal record here, since it's closer to the sure that the defendant is guilty, you can pretty well state that, yes, people with criminal records, if the jurors know about that ahead of time, that might influence them to find them guilty of whatever crime that they have done. All right, see if you can replicate what I have done here. There are 2 more practice problems. Pay attention to the alpha level in practice number 2. The alpha level is 0.01, so you would have to change that. And alpha level for this is 0.05, and this is another textbook one that I found in a textbook that we used to use about parachute suppliers, who supplies the stronger fiber for parachutes. All right, that's about all I have to say. It's Dr. Chasen. Practice, practice, practice. Remember, Dr. Chasen signing off.